Welcome everyone to ICONS2026. My name is Gabriel Silva-Atencio, and today I am excited to present my research titled A Dynamic Value-Based Pricing Framework for Productized APIs in Platform Ecosystems. This work addresses a critical gap in how we monetize digital assets within the computational science and engineering fields. As APIs transition from technical interfaces to standalone products, our economic models must evolve accordingly. Over the next 10 minutes, I will walk you through why our current pricing models are falling short and how a more sophisticated, algorithmic approach can unlock significantly more value for both platform providers and their users. This study represents a synthesis of platform strategy and advanced data science to provide a blueprint for future digital commerce. My goal today is to demonstrate that by shifting our focus from technical consumption to business outcomes, we can create more sustainable and profitable digital ecosystems for all stakeholders involved. Let's begin with the core issue, the API pricing mismatch. In the modern platform economy, APIs are no longer just technical tools. They are the fundamental building blocks of composable architectures and powerful network effects. However, while the technology has advanced rapidly, our pricing strategies have remained remarkably static. Most providers still rely on simplistic models like fixed monthly subscriptions or basic pay-per-call tiers. According to recent research, these models fail to capture the diverse multi-dimensional value that APIs create for different types of users. This creates a triple threat. Providers are leaving money on the table by undercharging for high-value usage. Consumers find their innovation stifled by rigid cost structures, and overall platform growth is hindered because the economic incentives are poorly aligned. Currently, there is a total lack of a framework that integrates algorithmic pricing with the complex dynamics of multi-sided platforms and principles of value co-creation. We are essentially trying to run a high-speed digital economy on an outdated analog billing logic, which is why a new paradigm is desperately needed to sustain long-term ecosystem health and support the next generation of digital products. To build a better framework, I first looked at three major bodies of literature, which currently exist as disconnected conversations. First, platform economics is excellent at explaining network effects and governance, but it tends to focus on the platform as a whole, ignoring the asset-level monetization needed for specific APIs. Second, the field of digital and algorithmic pricing has made great strides in real-time optimization, but these models are mostly designed for one-off transactions, like airline tickets or Uber rides, rather than the ongoing composable relationships typical of API usage. Finally, the API productionization literature describes various monetization categories but often lacks theoretical depth and fails to connect pricing to broader platform strategies or the concept of value co-creation. The missing link here is an operational framework that can synthesize these three streams into a single, coherent, and testable artifact. My goal was to bridge these gaps and create a system that is both theoretically sound and practically applicable for today's platform managers who need to balance technical performance with strategic business objectives. This led to my central research question. How can a robust framework for dynamic value-based API pricing be designed to account for diverse value realization modes, adapt to real-time ecosystem conditions, and support long-term platform flourishing? To answer this, I propose a three-part artifact. The first component is the value metric identification engine. This engine is designed to translate the abstract concept of value in use into quantifiable algorithm-ready metrics. The second component is the constrained multi-objective dynamic pricing engine. Unlike simple optimizers, this engine manages the inherent tension between maximizing revenue, encouraging rapid adoption, and minimizing customer churn all at the same time. The third and final component is the ethical governance layer. This is perhaps the most crucial piece, as it ensures that the dynamic nature of the pricing does not erode user trust. It provides the necessary transparency and fairness constraints to ensure that the pricing is seen as legitimate and reliable by all stakeholders within the ecosystem, turning pricing from a point of friction into a strategic asset. My methodology followed a design science research approach, utilizing sequential mixed methods to ensure both rigor and relevance. In the first phase, I conducted 27 semi-structured interviews with practitioners from 23 different organizations, covering roles in platform strategy, product management, and pricing. This qualitative exploration helped me reach theoretical saturation and understand the real-world pain points of API providers. I also analyzed the pricing pages of 45 major platform companies to see how theory compares to practice. In the second phase, I moved to the artifact design, using a card sorting exercise with 15 domain experts to categorize 42 different value metrics. This allowed me to formalize the multi-objective optimization function that drives the engine. Finally, for quantitative validation, I utilized agent-based modeling. I ran 1,000 simulations with different random seeds to test my framework against traditional benchmarks like static tiered pricing and pay-per-call models. I then applied rigorous statistical tests, including paired t-tests with Bonferroni corrections and Cohen's d-effect size calculations, to ensure the validity and robustness of the resulting findings. The first major result of this research is a comprehensive value metric taxonomy. Through the card sorting process, 6 distinct categories of value emerged. These are operational efficiency, such as cost savings, revenue acceleration, which involves faster time to market, risk reduction through improved security, transaction support for things like payment processing, ecosystem access to tap into network effects, and innovation enablement for creating new products. The key insight here is profound. Business outcomes, not technical consumption like the number of API calls, are the true drivers of value. For a long time, we have been pricing the container, the API call, rather than the content, the business impact. This taxonomy enables a fundamental shift from technology-focused metrics to business impact indicators. By identifying which category a specific API falls into, providers can choose the right metrics to feed into the dynamic pricing engine, ensuring that they are charging for the actual value they provide to the customer's specific business process. This alignment is the foundation of any value-based pricing strategy in a digital context. Now let's look at the dynamic pricing engine itself. The how of the framework. The heart of the engine is a multi-objective optimization function designed to maximize platform health. It calculates a utility score by balancing 3 key variables: normalized revenue, the rate of user adoption, and the probability of churn. These variables are weighted according to the specific strategic stage of the platform. For example, a new platform might prioritize adoption, while a mature one might focus on revenue. Crucially, the engine operates within hard ethical and operational constraints. First, price changes are limited to a maximum of plus or minus 15% per billing cycle to avoid sticker shock and maintain market stability. Second, every price change must be accompanied by an automated explanation to maintain transparency. The engine continuously recalibrates these prices based on real-time data, including usage patterns, competitor actions, and the achievement of the value metrics we identified in the taxonomy. This creates a living pricing system that responds to the environment while remaining predictable, fair, and logically sound for the users. The quantitative results from our agent-based modeling were highly encouraging. When compared against the best-performing static pricing models, our dynamic framework showed a 22.4% increase in provider revenue. But what is truly remarkable is that this didn't come at the expense of the users. Consumer surplus actually increased by 18.1%. These results were statistically significant with a high effect size, as shown by our ICONS-2026 values. The interpretation of these findings is vital. The framework achieves what we call Pareto gains, where both sides of the platform benefit simultaneously. This directly challenges the common zero-sum assumption that more revenue for the provider must mean less value for the consumer. By aligning the price more closely with the actual value realized, we can grow the entire economic pie. It proves that a more granular, dynamic approach to pricing is not just a way to squeeze more money out of users, but a way to create a more efficient and mutually beneficial marketplace where price reflects utility in real time. Beyond just increasing revenue, we also tested the framework's resilience and adaptability. We ran a stress test scenario where a competitor suddenly dropped their prices by 30% below the market average. Under this kind of intense competitive pressure, platforms using traditional static models saw a massive market share loss of over 17%. However, the platforms using our dynamic framework were far more resilient, losing only 4.1% of their market share. The statistical difference here was overwhelming. The dynamic engine's ability to sense competitive threats and adjust prices in real time provides a significant strategic advantage. It allows the platform to defend its position without engaging in a destructive race to the bottom on price across the entire user base. In the volatile world of platform markets, static models are essentially sitting ducks. They lack the agility required to survive rapid shifts in the competitive landscape, whereas a dynamic framework provides the strategic radar and responsive controls necessary to navigate these turbulent waters effectively while maintaining long-term profitability. One of the most interesting experiments we conducted involved the role of ethical governance. We wanted to see what happens if we remove the fairness constraints. When we removed the 15% price change limit, we saw a short-term revenue spike of nearly 9%. However, this gain was short-lived because the churn probability increased by a staggering 300%. Users felt exploited and quickly left the platform. On the other hand, we found that adding transparency, providing clear explanations for why a price changed, reduced churn by 42%. We also found a strong positive correlation between the use of business outcome metrics and long-term ecosystem trust. The takeaway here is clear. Ethical governance, including transparency and fairness constraints, is not just a nice-to-have or a moral obligation. It is a strategic necessity for maximizing long-term customer lifetime value and maintaining ecosystem health. This research shows that being transparent about pricing is actually more profitable in the long run than trying to hide the mechanics of the algorithm, as it fosters the trust required for deep ecosystem integration. To discuss the broader implications, this study provides the first framework to operationalize service-dominant logic for high-volume, automated API transactions. It successfully bridges the gap between macro-level platform strategy and micro-level pricing tactics. Theoretically, we have shown that value in use can indeed be formalized into algorithm-ready metrics, and that ethical design principles are integral to performance, not just external constraints. Practically, this research provides a clear roadmap for companies looking to move from static to dynamic value capture. It gives product managers a validated taxonomy to align their pricing with the actual outcomes their customers care about. While we have seen impressive benchmarks including a 22% revenue increase and 42% churn reduction, we must acknowledge some limitations. Our results are based on agent-based models and require further real-world validation through longitudinal field studies. Additionally, heavily regulated industries like finance or healthcare might require more specialized metric sets, and we haven't yet addressed the internal organizational challenges of cross-functional alignment between sales, product, and engineering teams. In conclusion, this research presents a blueprint for the next generation of value-based API monetization. We have summarized 4 key innovations: a value metric taxonomy, a multi-objective pricing engine, an ethical governance layer, and empirical validation through simulation. The key takeaway is that static pricing models are a relic of the pre-platform era. To flourish in the future, platforms must embrace value-based dynamic pricing governed by ethical constraints. Looking forward, we plan to conduct field studies in live environments and adapt the framework for regulated industries. We also want to model more complex consumer behaviors and integrate these engines directly into real-time analytics infrastructure. Thank you for your time today. I hope this framework provides you with new ways to think about the intersection of technology, value, and economics in our digital society. I am now open to any questions you may have about the methodology, the metrics, or the implementation of these findings in your own organizations.